Hello, my dear students. Today, in this lecture, we are going to solve some of the problems on Carnot cycle and ideal Rankine cycle. Let's see the problem number 1. Here in first problem, they say the Carnot cycle has a boiler pressure of 16 bar and a condenser pressure of 0.05 bar. So this Carnot cycle is working between the two pressure limits 16 bar and 0.05 bar. Determine the following. So we need to find out the turbine work, condenser work, compressor work, efficiency and work ratio. So let us go back. Let's see what is the Carnot cycle. Here 1 to 2 is the isentropic work done in the turbine. 2 to 3 is isothermal and also constant pressure heat rejection in the condenser. 3 to 4 is the isentropic compression or the pumping work, and 4 to 1 is the isothermal heat addition in the boiler. So turbine work is H1 minus H2. Condenser work is H3 minus H2. Compressor work is H4 minus H3. And the efficiency of the cycle, so for a Carnot cycle, you have seen that efficiency is equal to 1 minus TL divided by TH. That is saturation temperature at the condenser divided by saturation temperature at the boiler and the work ratio. See now, first thing what you need to do is write a tabular column of for the pressures, that is boiler pressure and the condenser pressure, and obtain these enthalpy and entropy values from the thermodynamic data handbook. So here HF, as you know, 16 bar at 16 bar, that is, this is 16 bar pressure. At 16 bar, HF is enthalpy of the fluid. That is, enthalpy of the fluid means lying on this saturated liquid line. It is nothing but your H4 here. And HFT is the latent heat. That means heat required to convert the saturated liquid to saturated vapor. Hg is the enthalpy of the saturated, enthalpy of the steam, that is dry saturated. Here the point number 1. This is 1 lines on the dry saturated line. Similarly, SF, this is the entropy of the liquid. Entropy of the liquid on the saturated liquid line. SFG is the entropy required to convert from liquid to steam. It is latent heat. Sg is the point lying on the dry saturated line. That is entropy at 16 bar pressure lying on this dry saturated line. That is point number 1, S1. And T saturated is saturation temperature at for the pressure 16 bar. Similarly, obtain the values for condenser pressure of 0.05 bar. So obtain HF value. HF is again point lying on this saturated liquid line. This here point will lie on the saturated liquid line. And HFG is enthalpy of the required to convert from saturated liquid to saturated vapor. This Hg is the point lying on this dry saturated line. Similarly, SF is the entropy on the saturated liquid line. Sg is the entropy on the saturated vapor line for 0.05 bar pressure, and the saturation temperature is 32.9. These values are obtained from the thermodynamic data handbook. Now, once we obtain these data from the data handbook, to calculate or determine the things as in the problem, first thing we need to do is obtain the values of H1, H2, H3 and H4. Since, as I said, turbine work is H1 minus H2, so we need to obtain the values of H1 and H2. So H1 is nothing but the point, this point is lying on the dry saturated line on the boiler for boiler pressure. So for PB and point H1 is at Hg at boiler pressure. So go to 16 bar pressure. At 16 bar pressure, Hg value, that is 2791.7. This is, see, Hg at Pb 2791 is your H1 point. Can you find H2 point directly? No, because this 2 point lies in the wet region of the steam. It is not on the dry saturated line or the saturated liquid line. It is in the wet region. So how to find H2? What is H2 is nothing but HF2 plus X2 into HFG2. How to find X2? What is X2? X2 is the dryness fraction of the steam at the point 2. How to find dryness fraction X2? X2 is obtained from the process 1 to 2. What is process 1 to 2? It is isentropic expansion process. Isentropic process means entropy remains constant from 1 to 2. So, first step is you need to equate S1 is equal to S2. What is S1? S1 you can directly get because it is on the dry saturated vapor line. So S1 is equal to Sg on, for the pressure 16 bar. So go to 16 bar Sg pressure. It is for the pressure 16 bar. So what is the value of Sg? 6.4176. So write down S1 equals 6.4176. That should be equal to SF2 plus X2 into SFG2. So what is SF2? 2 means it is condenser pressure. So on the condenser pressure line, SF2 means here point here on the saturated liquid line. So go to condenser pressure, SF, that is 0.4763. So that is your SF2 plus X2. This is the one we need to find out, that is dryness fraction. Multiply by SFG2. What is SFG2 means? 2 point means pressure 2, that is condenser pressure. Go to SFG, that is 7.7196. So X2 into 7.197, sorry. So if you obtain, substitute here and simplify, you'll get the value of X2 as 0.75. That means dryness fraction after the steam expansion is 0.75. So once you get the dryness fraction, calculate the value of enthalpy at point 2. So H2 will be equal to HF2 plus X2 into HFG2. Substitute the values of HF2 plus X2 is 0.75 and HFG2, you'll get the value of H2 value. Next thing you need to find out H3. Again, it is not possible to get the H3 value directly because it is again in the wet region. But we can get the value of H4 because it is on the saturated liquid line. So what is H4? On the boiler pressure line, saturated liquid and on the saturated liquid line. So go to boiler pressure, saturated liquid, that is, and enthalpy of the saturated liquid, that is HF is nothing but 858.5. Now, but not with H. This is 3 to 4 is isentropic. So we have to get the value of SF. What is SF at boiler pressure? 2.3436. Right? So S4 is equal to S3. So what is S4? S4 is equal to 2.3436. That should be equal to S3. SF3 plus X3 into SFG3. What is SF3? 3 point lies on the condenser pressure. SF3 means it is on the saturated liquid line. Go to boiler pressure, sorry, condenser pressure, and here SF value is 0.4763. So it is 0.4763 plus, sorry, here, plus 0.4763 plus X3 into SFG3. What is SFG3? Again, on the condenser pressure, go to SFG. It is 7.9197. 7.9197. So get the value of X3. Once you get the value of X3, H3 is found out as H3 is equal to HF3 plus X3 into HFG3. So get the value of H3. So once you get the value of H1, H2, H3, H4 is what? H4 is directly on the saturated liquid line on the boiler pressure. So directly we can get the value of H4 is equal to HF at boiler pressure PB. So HF at boiler pressure is 858, substitute here. So now we got all the four enthalpies, H1, H2, H3 and H4. Now solve one by one. First case is the turbine work. What is turbine work? H1 minus H2. So H1 minus H2 is your turbine work. Just substitute H1 minus H2. You will get the turbine work. Next is condenser work. What is condenser work is H3 minus H2. So H3 minus H2 is your condenser work. What is compressor work? Compressor work is 3 to 4 is compression. So H4 minus H3 is your compressor work. H4 minus H3. Now, then what is efficiency? Efficiency is equal to turbine work minus condenser work divided by heat supplied. So substitute. What is heat supplied? Heat supplied will be during in the boiler. So H1 minus H4. So QS is nothing but H1 minus H4. And we get the efficiency of as 35.5%. What is work ratio? Work ratio is the actual work done, that is turbine work minus condenser work divided by turbine work minus compressor work. So work divided by turbine work. So turbine work is 836 minus compressor work is 149.2 divided by turbine work, we get the work ratio. Now let's go to the second problem. This is the problem which is a recent problem. It was asked in January 2018. In a steam power cycle, the steam supply is at 15 bar. That means steam supply means it is boiler pressure is at 15 bar and dry saturated. So he has already given that the point number 1 lies on the dry saturated line. Next, condenser pressure is zero point 0.4 bar. So that means here the condensation occurs at zero point 0.4 bar pressure. Calculate the Carnot and Rankine efficiencies of the cycle and neglect the pump work. So you need to find out the Carnot as well as Rankine efficiency. So write down the TS diagram for a Carnot cycle and Rankine cycle. So as I said, what is the difference? This point number 3, right, lies on the saturated liquid line in the Rankine cycle. And 3 to 4 is a pumping work, 4 to 1 is the heat supplied in the boiler, where 4 to 5 is the sensible heating, at 5 evaporation of the steam takes place in the boiler. Now, so first step what you need to do, obtain the values of enthalpy and entropy and saturation temperature for boiler pressure and condenser pressure. Now, so now first case, we need to find out efficiency. Go for the Carnot cycle. For the Carnot cycle, directly we can use the efficiency formula. Efficiency equals 1 minus temperature, saturation temperature at the condenser divided by saturation temperature at the boiler. So directly saturation temperature obtained as for the condenser is 75.89, converted into Kelvin scale. Again, the temperature for the boiler, saturation temperature is 198.28, convert to Kelvin. So you'll get the efficiency of 25.96 as the efficiency for a Carnot cycle. Now, for the Rankine cycle, you cannot directly use any of the equation. You have to go by the traditional process of net work divided by heat supplied. So net work is turbine work minus pump work by heat supplied, and here he has given neglect pump work. That means 3 to 4 is the pump work. If we neglect pump work, then 4 point should almost come to 0.3. Right? So that means H4 will be equal to H3. So I'm neglecting pump work. So what will be the Rankine cycle efficiency will be equal to turbine work by heat supplied. So turbine work is H1 minus H2. Heat supplied is, it should have been H1 minus H4. Since H4 is equal to H3, we have taken heat supplied as H1 minus H3. So H1 minus H3. Now, once we write down these things, now what we need to do, we need to obtain the values of H1, H2 and H3. So where is the H1 point? H1 point is lying on the dry saturated vapor line. So directly for the boiler pressure, dry saturated Hg value. So for the boiler pressure, what is the Hg value? 2791, sorry, 2789.9. So this is the point where the steam is entering the turbine. That is the point number 1. So you get the value of H1 directly, 2789.9. Now again, as I said in the previous case, 1 to 2 is isentropic expansion, and since 2 is at the wet steam, the value of dryness fraction is not known. We have to use the condition S1 is equal to S2. How do you get S1? S1 is directly obtained from the table, since it is nothing but on the dry saturated line, Sg value. So S1 will be equal to 6.4406. So take the value of S1, 6.4406, that should be equal to S2. What is S2 is equal to SF2 plus X2 into SFG2. How to get the value of SF2? SF2 is 1.0261. How do you get this? So go to the table. So condenser bar for the condenser pressure, S2 means the point should lie on the should lie on the saturated liquid line. So go to saturated SF 1.0261, SF2 plus X2 we do not know, we need to find out, into SFG. What is SFG value on the condenser pressure? 6.6448. Now substitute here, get the value of X2. Once you get the value of X2, go to the enthalpy equation. H2 equals HF2 plus X2 into HFG2, and we know the value of H2, HF2 and HFG2. What is HF2? Again, on the condenser pressure, this is 317.7 is the HF2. HFG2 is 2319.2. So substitute these two values, and with the X2 of 0.815, get the value of H2. Once you get the H2, then go to H3. How to H3? Where the 3 point is lying is on the liquid line. So directly for the condenser pressure, liquid point lying on the saturated liquid line. So go to HF point, that is 317.7. So get the value of H3 317.7. Then obtain the efficiency. What is efficiency? Turbine work H1 minus H2 divided by heat supplied H1 minus H3. Substitute, you'll get the value of efficiency. This is the Rankine efficiency. Next, the next problem is the problem number 3. This was asked in June 2017. Here, the steam power plant operating on an ideal Rankine cycle. So directly they have given it as it is operating on an ideal Rankine cycle. Steam enters the turbine at 20 bar with an enthalpy of 3248. See here in this problem, they have directly given the enthalpy values and an entropy value of 7.127 for the boiler pressure 20 bar. So they are not directly specified where the point number 1 lies on the TS diagram. Now, the condenser pressure is 0.1 bar. So condenser pressure is 0.1 bar. Find the cycle efficiency and the specific steam consumption. So you need to find the specific steam consumption. And one thing you see here, do not neglect the pump work. That means we have to include the pump work. In the previous case, pump work was neglected, but here we need to include the pump work. So now again, go to the data handbook. For the boiler pressure of 20 bar and condenser of pressure of 0.1 bar, obtain the enthalpy and entropy values as well as the saturation temperature values. And here I have added one more, that is volume of the fluid. So VF value has been also obtained from the data handbook. Then now for the next step is get the values of H1, H2, H3 and H4. So now, what is H1 value? They have directly given us 3 to 4, right? But where the point 1 lies, is it on the dry saturated line or the superheated region? How do you check? So go to the boiler pressure and boiler pressure Hg line. What Hg enthalpy? How much is the value? 2797.2. But what is the value given? 3248. That is enthalpy at point 1 given is higher than the enthalpy at the dry saturated point. That means when it is higher means this point is lying in the superheated region. Next, and S1 value also directly given. Then, right? So S1 is equal to 7.127 kilojoules per kg Kelvin. Now, so we know H1 and S1 directly. Now, point number 1 is in the superheated region. Again, next 1 to 2 is the expansion of the steam in the turbine, and the 2 point lies in the wet region. We do not know the value of X2. So, how to find the value of that is the dryness fraction or at point 2 is obtained by using again the same step. S1 is equal to S2, that is isentropic process. So S1 value directly we know, equate it to S2. S2 lies on the condenser pressure. SF plus X into SFG at 0.1 bar pressure. So get the value of X. X is equal to S1 minus SF at zero point 0.1 bar pressure. What is SF at 0.1 bar pressure? 0.6493. It is 0.6493 divided by SFG at 0.1 bar pressure. Go to 0.1 bar pressure, SFG 7.5018. 7.5018. From this, get the value of dryness fraction at 0.2. Once you get the dryness fraction, obtain the value of enthalpy at 0.2, H2. H2 is equal to HF plus X into HFG. So where you have to find the HF and HFG values, this is on the boiler pressure. So HF value on the boiler pressure is 191.8 and HFG value is 2392.9. So substitute here, get the value of H2. Next, H3 value. So directly we can get, this is on the condenser pressure at 0.1 bar pressure. HF value, that means point lying on the saturated liquid line. So it is 191.8. Directly we can obtain H3 value. Now, there as the pump work, you should not neglect the pump work. So pump work is obtained by, as we have already studied, the work will be work we have studied as PDV work or VDP work. So PDV work, when pressure is constant, volume is changing, and here volume is remaining constant because volume of the fluid will not change here. So volume is remaining constant. So we am taking as VDP work. VDP means volume of the fluid remaining constant. DP, pressure is changing from condenser pressure to, because you are pumping here from condenser pressure to boiler pressure. So use this expression, WP is equal to, is nothing but H4 minus H3 will be equal to VF3. VF3 is volume of the fluid into boiler pressure minus condenser pressure. So what is the pump work? So boiler pressure is 20 bar minus condenser pressure is zero point 0.1 bar, and please listen carefully. Here I am multiplying by 10 power of 2. That means pressure is in bar, but I am converting into kilopascals. So so that I can get the value of H4 in kilopascals. So sorry, kilojoules per kg. Kilojoules per kg. So efficiency now, it is, how do you obtain the efficiency? Turbine work minus compressor work. Turbine work is H1 minus H2 minus pump work H4 minus H3 divided by heat supplied H1 minus H4. So once you get all the values, substitute here and you will get the efficiency value. So we have got of 32.3% as a efficiency. And then we have to find the specific steam consumption is given by 3600 by turbine work. So 3600 divided by, because this is turbine work, we have it in per second. So in per hour means, so 3600 seconds. So 3600 divided by WT. What is WT? H1 minus H2. So we will get it as 3.636 kgs per kilowatt hour. Thank you.